Okay, so I think this is going to be my last Chapter 2 example problem, and it's going to be based off of the supplemental videos of rocket launches. I was really psyched when I looked on YouTube and I found out that at least a couple of people had mounted cameras on their model rockets and launched them and then posted the videos on YouTube, because it's exactly more than I could have hoped for in order to do this example problem. So you should watch the rocket launches, and this is going to be based off of those. Okay, we got two phases. So we have two phases in the rocket launch. We have the rocket firing, and then we have free rise is what I'm going to call it. And then also we could actually add into there free fall, like the fall under the parachute, but I'm actually not going to worry about what happens after the parachute deploys. I'm just going to talk about the rocket going up. Okay, so we've got X, T, VI, VF, A, and this is going to be just when you see the big, huge amount of steam and smoke coming out of the back of the rocket. So there's like a very quick burst with it where the rocket motor fires, and then for the rest of the flight, the rocket motor is still putting out exhaust, but it's not on anymore. It's not really providing thrust anymore. And so after the rocket motor does its thing, it's going to just coast up to a stop. Okay. Now, what we know we can do is we know that when it's going up without the motor on, it's going to be accelerating back towards the surface of the Earth at negative 9.81 meters per second squared. And we know when it gets to the top of its flight, it's going to be going 0 meters per second. And now watching those videos, it seemed to me that there was about 10 seconds between when the rocket motor stopped firing and when the rocket got to the top of its flight. So that allows us to solve for those two very quickly, and that's what we're going to do. We're going to jump in right with this one. We're going to say A equals VF minus VI over T, and we're going to solve that. We know VF is 0, so we're going to say that negative AT is going to be equal to VI, and so negative 9.81 meters per second squared times 10 seconds is going to be VI, and so VI is going to be 98.1 meters per second. So when the rocket motor cuts out, it's going 98.1 meters per second. Now, so that's the final velocity over here for the rocket firing. So for the rocket firing, it ended up at 91 meters per second. And when the rocket was on the launch pad, before the rocket fired, it was going 0 meters per second. So what's going to happen is it's on the launch pad, it accelerates to 98.1 meters per second, and then the rocket motor stops, and then it slows down from 98.1 meters per second to 0 meters per second under the influence of gravity. And now, I think just as an estimate, looking at those videos as just a rough estimate, we see that the rocket fired for about 1 second, and so that's going to actually give us an acceleration from this phase of 98.1 meters per second squared, or about 10 Gs, about 10 times the force of gravity. Okay, Now let's just figure out how far it goes. Well, when the rocket is firing, let's use these. X is VI plus VF over 2 times T. So X is going to be 0 plus 98.1 meters per second divided by 2 times 1 second. And so X is going to be 98.1 divided by 2. It's going to be about 49 meters. Now, the last one we're going to do is over here. It's going to be almost exactly the same thing. 98.1 meters per second is where it starts out. 0 meters per second is where it ends up. 2, but now this is 10 seconds. And so X is going to be approximately 490 meters. So total height is equal to 490 meters plus 49 meters. So it's going to be approximately 539 meters, or approximately 540 meters. Okay, so what's happening in that video is roughly, this is rough numbers, you'd have to calculate it out exactly using exact times and everything, is that the rocket motor is on for 1 second. And in that 1 second, it accelerates the rocket with an acceleration of 98.1 meters per second squared. So at the end of that acceleration, it's going 98.1 meters per second, and it's gone up a distance of 49 meters. Now, when the rocket cuts out, it's going at 98.1 meters per second, and then the acceleration is negative 9.81 meters per second squared, so it's going to accelerate up for a remaining 10 seconds, and after 10 seconds it's going to be going 0 meters per second. It's going to start falling back towards the Earth, and in that 10-second interval it goes up an additional 490 meters, and so the total height between this phase and that phase is about 540 meters is how high that rocket goes, which is a long ways. Half a kilometer is a long ways, but if you look at these videos you see that they go a long ways up. Okay, that's that video.